Good evening and welcome to this session number 17 from the chapter of moving charges and magnetism. The topic is the Ampere's circuital law. So the first point here is the definition of it, and the Ampere's circuital law states that the line integral of magnetic field around a closed loop is proportional to the net electric current passing through the loop. So in order to understand this definition, I have made one diagram here. So this is a closed loop. This is a closed loop, and in this closed loop, there is one current I1, there is one current I2, and there is one current I3, which is flowing through this closed loop. Now here, the current which is depicted by a dot is directed out of the plane, and in physics it is normally taken as positive. So, and the current which is directed into the plane is typically taken as negative in physics. So here the net current which is passing through this closed loop, this is equal to I1 plus I2 minus I3. So if I use this Ampere's circuital law, this equation, then mathematically Ampere's circuital law is given by this equation, that is the line integral of the magnetic field around a closed loop. This is equal to mu naught times the net current. Now here the net current here is equal to I1 plus I2 minus I3. Again, the current which is directed out of the plane is taken as positive, and the current which is directed into the plane is taken as negative. So the net current through this closed loop will be equal to I1 plus I2 minus I3. So mathematically, the line integral of the magnetic field around this closed loop will be equal to mu naught times the net current, and the net current here is I1 plus I2 minus I3. So in this case, the equation becomes this. Now the Ampere's circuital law is very effective in calculating the magnetic field in the conductors, in the solenoids, and in the toroids. So we will be studying about these in the subsequent sessions. But in the next session, that is in the session number 18, I will be discussing one simple numerical problem which will be based from this topic of Ampere's circuital law. So till then, have a nice day. Bye.